Hello friends, welcome back to our channel. So in today's session, let us have a look on the concept of operating system. So from today I am just going to start uploading the videos on operating system as well as the Python programming. So in the coming days, so you can expect almost every concept of operating system and Python programming in our channel. So keep following our channel, and today let us have a look on the operating system concept, that is a process state diagram. It's a very important topic. Process state diagram. First of all, what is meant by a process? A process is defined as the program under execution. So whatever the program we are executing, that we call it as a process. So the process, the creation of process, from the creation of the process and the termination of the process will change its states. That means the process is executed in different states. So there are different states. One is new state. So if the process is about to create it, then that process will be in this new state. Process about to create, then it is called a new state. So after this new state, that means after the process is created and then it's ready for execution. If the process is ready for execution, we call it as ready state. Then immediately the process will be moved to the ready state. So if the process is ready for execution, and right, so at a time in the ready state, a number of processes can be residing. Right, depends upon the memory, number of process can be in this ready state. That means more than one process can be in this ready state. So from this ready state, whenever the CPU is free, each process will be allocated to the CPU. So that we call it as running state. Running state. That means allocating the process to the CPU for execution. Right. So this is allocating process to CPU, that is a processor for execution. So after allocating the process to the CPU, so the CPU will execute complete its execution, and once the execution of the process is completed, then that process will be in termination state, terminated. That means if the process execution is completed, then the process will be in terminated states. So after completion of process execution, right? These are the four states, major states. So without any interruption, if the process wants to be created and if the process wants to be executed successfully, minimum number of states required is 4. New state, if the process is about to be created, and after creation of the process should be moved to the ready state, and from that ready state the process will be allocated to the CPU, and then after completion of the process will be in terminated state. Right? So here the execution will be done in two ways. One is preemption and non-preemption. That means if here from the ready to running state, if the process wants to move from ready to running state, So here in the running state, we are allocating the process to CPU, right? So if it is a preemption, if there are any high priority process is available in the ready state, automatically the executing process, the process which is going execution, will be interrupted and the high priority process will be allocated to the CPU. That is called preemption. So if there is a high priority process, then the already executing process will be interrupted. If there is high priority process, and in the non-preemption, it doesn't worry about the higher priority process. Once the process is allocated to the CPU, it will be executed. Only after executing that particular process, next only the second process will be allocated to the CPU. Whereas in the preemption, depends upon the priority of the process. If there is a high priority process available in the ready state, automatically the current process which is allocated to the CPU will be interrupted and this high priority process will be allocated to the CPU. So switching of the process will be done. So that will be done, it is called a preemption. And if one process is executed, if one process is in the running state, until it completes its execution, no other process will be entered into the running state. That is called non-preemption, no interruption. So no interruption. So here we can write interruption. If it is high priority process, the process with high priority, right? This is a non-preemption. And similarly, if the process is going to be executed, it requires two terms. So for every process, it requires two terms. One is CPU time and another one is IO time. For every process, there will be CPU time and IO time. So what is the CPU time? So how much time it requires for the CPU to execute this process? That means this will be done by the CPU. All the CPU operations, the computations will be done by the CPU. That is called a CPU time. And IO time. IO time means if the process needs some IO request or IO operations, and so that is called IO time, and this is done by the IO devices. CPU time and IO time, right? So if the process is in IO time, the CPU will be in idle. If the process is in CPU time, the IO devices will be in idle. So if the process is in IO time, that means if the process requires some IO operations to be executed, then automatically there is one more state called block state or a wait state, and another process will be allocated to the CPU. That means one more process from the ready to run will be done. So the current process which requires these IO operations will be moved to the block state. If IO operations, if it requires some IO operations, these IO operations will be done by the IO devices, right? Okay, so these are the different states: new, ready, running, terminated, and a block and wait. And this process execution will be done in preemption and non-preemption. That means from ready to running, it may be preemption and non-preemption. If it is interruption with interruption, that means based upon the priority of the process, automatically the current process will be suspended and the new process with high priority will be allocated to the CPU. And if in the non-preemption, no interruption will be there. So until the completion of the current process, no other process will enter into the running state. Right? Now let us see the diagram so that you can clearly understand. See, first one, new state. That means the process is about to be created. So after creation of the process, then that process will be moved on to the ready state. The process will be in a ready state. From the ready state, if the process is ready to execute, this process will be moved on to the running state. That means in the running state, the CPU will be, the processor will be allocated to the particular process. So this is done. So in this ready state, number of processes can be resided. So it can allow more than one process in this ready state. So among those many processes, the scheduler will schedule each process to the CPU. So this is CPU. So here the scheduler will schedule each process to the CPU. This is also called as dispatcher. You can call anything dispatcher. And after successful completion of the process, it will be moving on to the terminated. So after completion of execution, it will be in the terminated state. Right? So this is the process done without any interruption. That means non-preemption. And if there is a preemption, right? So as we have discussed earlier, the preemption means interruption. So the priority, based upon the priority of the process, the current process will be suspended and the higher priority process will be assigned to the CPU. So if it is preemption, interruption will be there. When it will be, if we are getting the high priority process, that means a process with high priority, automatically the current process will be again moved to the ready state. And if the process requires IO operations, again the process will be moved to the wait state. See, IO request, right? If it requires some IO operations to be performed, those IO operations will be performed by the IO devices. So until that process completes, so that process will be moved to the wait state. And from after completion of these IO operations, again the process will be moved from wait state to ready state. So IO completion. Hope you understood this, right? So then here this is the secondary memory. Right? The process creation, everything will be in secondary memory. And after completion of the process creation, the process will be moved to the ready state, which is in main memory. And this is also the main memory. And this is also the main memory. Right? If this main memory is full with the current process, and again the new process is coming to the wait state, some processes will be suspended, move to this state, suspended state, wait suspended state. So if this memory is full, with the processes which are going on this IO request, that means IO operations, some of the processes will be moved to the wait suspended state. So again, this is a secondary memory. So after completion of, after availability of main memory, again these processes will be moved on to this wait state. That is again main memory. This is called, this is suspended, this is resume. Some process, if the memory is full, some process will be moved to the wait suspended, and wherever the memory is available, again from this suspended state the process will be moved on to the wait state. Similarly here also. Here, as we said, that ready is a state which can hold more than one process, right? So here also, if the main memory is full, automatically some process will be sent to the suspended, ready suspended. This is again secondary memory. And after completion, after completion means here after availability of the main memory in the ready state, if the main memory is available, again this suspended will be resumed back to ready state. In some cases, from this wait suspended to ready suspended, the process will be moved from wait suspended to ready suspended. So once again I am saying, here it is a secondary memory. So moving this process from new state to ready state, that means the process moves from secondary memory to main memory. And here the main memory ready state, there will be number of processes based upon the scheduling algorithms. There are different algorithms. So based upon the scheduling algorithms or a dispatcher, we will pick up one process and it will be allocated to the CPU. And if there is any interruption, that means a preemption. If the algorithm is a preemption, that means we have to give the highest priority to some processes. So in such case, the process already in a running state will be again moved to the ready state, and it will be again waiting for the CPU, right? So if the running process requires some IO operations to be performed, then it will be moved to the wait state. And after completion of the IO operations, again from the wait state, the process will be moved to the ready state and again waiting for the CPU. So here this is a main memory. Wait state is a main memory. So if here this main memory is full, so there is no space to accept the process. So some of the process will be moved to the wait suspended state, which is in the secondary memory. And whenever the wait state, the main memory is available, this from the wait suspended, the process will be resumed to the wait state. Similarly, the ready state, right? So this process, that means moving from secondary memory to main memory, this process we call it as long-term scheduler. That means this long-term scheduler work is to send this process from new state to ready state, from secondary state to it loads the process to the main memory, and from the main memory we have to allocate the CPU to the processes. That work will be done by the short-term scheduler. Short-term scheduler, right? So this process from the ready state to running state, right? Again, with the high priority, again it will be ready state. So this scheduler, scheduling the process, that means allocating the process to the CPU, that will be done by the short-term scheduler. And coming to this wait suspended and ready suspended. So some process will be in wait suspended, and after the main memory available, again this suspended, the process which is in wait suspended will be again moved to the wait. So this work will be done by the midterm scheduler. Right? So hope you understood this simple thing. There are three schedulers here. One is long-term scheduler, short-term scheduler, and mid-term scheduler. and the process can be executed in a preemption or non-preemption, and each process may require CPU time or IO time. So CPU time means the processor working by the processor, executing by the processor, and the IO time means the processor, if the process requires some IO operations, so that will be done by the IO devices. So these are a simple thing of process state diagram. So let us stop here for the today's session. So hope you understood this process state diagram. It's a very simple. So the different states involved in the process execution, right, and different schedulers. There are 3 schedulers, and the CPU time, preemption, non-preemption, and the IO time. Everything I hope you understood. So if you are having any doubts regarding this one, feel free to post your doubts in the comment section, so that I will definitely try to clarify your doubts. So if you really understood my videos, like my videos and share my videos with your friends, and don't forget to subscribe to our channel. So in the coming days, I am going to start uploading the videos on operating system as well as the Python programming. Right? I will try to cover every concept of operating system and Python programming. So keep watching our sessions, keep following my sessions, and don't forget to subscribe to our channel. Thank you very much.